Exercise 7.2 Problem 14 Discussion. A straight highway leads to the foot of a tower. A man standing on the top of the tower spots a van at an angle of depression of 30 degrees. The van is approaching the tower with a uniform speed. After 6 minutes, the angle of depression of the van is found to be 60 degrees. How many more minutes will it take for the van to reach the tower? Okay, it's an interesting problem. Let's draw a simple diagram. So how will you draw a simple diagram? Just draw one tower, okay, a vertical line and an horizontal line, and mark 2 points on it, the initial position and the final position of the van, and then connect the lines. Okay, right. So this is a tower. Okay, this is a horizontal line which is a earth level or the level of the eye. Okay, and mark the 2 points, initial position and final position. So the van is moving from this to this direction, right? And connect these 2 points. Have you got? And draw one more line because it's angle of depression, right? Because he's seeing it from the top. So this is his eye level, which is horizontal. This and these 2 lines are parallel to each other. So angle of depression is, this is what is our first angle of depression. So when he sees from here to this point B, this is the angle of depression. But we know this line is parallel to this line. So this 60 degrees is also equal to this 60 degrees. The same goes here. Join these 2 lines, and the angle of depression for this is 30 degrees. So join these 2 here, and this angle is this angle. Okay. Now you have marked all the information. So let me repeat. This is the tower. This is the initial position of the van, and this is the final position of the van. And we are asked to calculate how much time will it take for the van to reach B, because it takes 6 minutes to move from here to here. There are 2 ways of doing it. You can actually calculate the distance, and if you are given the speed, then you can calculate the distance and find the time. But here they have not given the distance, and I don't think we'll be able to find the distance. The easiest way is, see, it takes from here to here is 6 minutes, and we need to find AB, the distance or the length AB in terms of BC. So now let's say AB is half of BC. And it is traveling at the uniform speed, right? We can see it here. It's at a uniform speed. So from B to C takes 6 minutes, and A to, or B to A, which is half the length of BC, means if it is so, then it will take 3 minutes, right? It will take half of 6 minutes, that it will take 3 minutes. So this is another way of doing it. Next, 60 degrees is given, tan 60. You'll have to take tan 60. So AD by AB will be tan 60. So you can get a relationship between AD and AB, right? For tan 30, it will be opposite side, AD by adjacent side, AC. So again, you will get AD in terms of AC. Equate the 2 equations, because you have AD from this triangle and you have AD from this triangle, right? Equate those 2 ADs, you will get a relationship between AB, BC, AB and AC. Then you have one more relationship, AB plus BC equal to AC. So using these 3 equations, you will be able to get AB in terms of BC. Once you get AB in terms of BC, then you can use this information. For example, if AB is half of BC, then the time taken for the van to go from here to here will be half of 6 minutes, right? That will be 3 minutes. So this is how this problem is to be solved. Anyway, let's mark everything. The man is standing on top of the tower. The angle of depression, the van is moving. Initially, the angle of depression was 30 degrees. It is moving at an uniform speed. After 6 minutes, the angle of depression is found to be 60 degrees. How many more minutes will it take for the van to reach the tower? So the initial position, and the van is this is the tower. The van is moving towards the tower, right? And this is the final position, right? And it takes 6 minutes for it to move from here to here. Now they want to know how much more time will it take for it to travel from B to A. So this is a question, right? So let's list out. 2 angles of depression are given, 30 degrees and 60 degrees, and time is given 6 minutes. We need to find the time the van will take to reach the tower. Typically, tan theta equal to opposite by adjacent will be used. Then you have one more relationship, AC will be equal to AB plus BC. Then another hint is, get the equation of AB in terms of BC. Get an equation of AB in terms of BC. Basically what I mean to say is that write AB in terms of BC. is AB equal to BC, or AB equal to half of BC, or AB equal to quarter of BC, whatever it is. If you get that relationship, then you can use this information and get the time. If we say it is quarter, if AB is 1/4 of BC, so the time it will take to travel AB will be 1/4 of 6 minutes. That will be 1.5 minutes, right? So that kind of relationship you need to get. Keep that in the back of the mind. Let's work it out. So draw the rough diagram and mark all the mark it and get the values. Okay. Okay. Step 2. In the triangle ABD, substitute value of theta, the angle of elevation. Actually, it's angle of depression, but anyway, this is angle of depression. When it comes here, it becomes angle of elevation. So both are the same. In the formula, tan theta equal to opposite by adjacent. So which is basically equal to AD by AB. So tan 60 is opposite by hypotenuse, that is AD by AB, correct? Opposite is AD and this is AB. So you are getting AD in terms of AB because tan 60 we know. So you will get a relationship between AD and AB, or you'll get AD in terms of AB. Okay, right. Next, do the same for the triangle ACD, for the bigger triangle ACD. Okay, tan 30 will be equal to opposite, that is AD divided by AC. Okay, again we'll get AD in terms of AC. Next, what you do, you in the first triangle also you got AD in terms of AB. In the second triangle also you got AD in terms of AC. Equate the AD. Okay, eliminate the AD between the equation 1 and 2. You will get a relationship between AB and AC. Next, one more relationship which you have is AB plus BC equal to AC. Use that and get AB in terms of BC. This is a key. We have to get AB in terms of BC. AB is half of BC, or AB equal to half of a quarter of BC, something like that. Once you get that, you know the time taken to travel BC is 6 minutes, and if it is quarter, then the time taken to travel AB will be quarter of 6 minutes, that is 1.5 minutes. Something like that we'll have to get. Some relationship between AB and BC. That is our final goal. Okay. So then I think let's go to the solution. I don't think we'll be able to do it. Let's do it, and then after seeing the complete solution, you try to work it on your own. Okay. Right. So let's get into the solution. So AD is the tower, and C is the initial position, and B is the final position of the van. Okay, and the angle of depression is 60 degrees here. So that is, this becomes 60 degrees, and for the first position is 30 degrees. So this is 30 degrees. So consider the triangle ABD. Okay, right. So tan 60 will be opposite by adjacent, right? So that will be tan 60 is AD by AB. So AD by AB is tan 60, which is root 3, or AD will be equal to root 3 AB. Now you got AD in terms of AB. Similarly, try this triangle AC and D, right? So tan 30 will be opposite divided by adjacent, that is AD by AC. Tan 30 is AD by AC. Next, so AD by AC will be equal to tan 30, and tan 30 is 1 by root 3, and AD will be equal to AC by root 3, and you don't like to have root 3 in the bottom, so you multiply numerator and denominator by root 3. It becomes root 3, and root 3 into root 3 becomes 3 here. So AD equal to root 3 AC by 3. Now, earlier we had AD equal to root 3 AB, and you have AD equal to root 3 AC by 3, right? So equate the AD from both equation 1 and 2. You will get AD, which is root 3 AB, okay, equal to root 3 AC by 3. AD is so much as per equation 2. Let's go back. And AD is root 3 AB as per equation 1, right? And since AD is the same, so root 3 AB will be equal to root 3 AC by 3. That is what we have done here, right? Now this root 3 and this root 3 will cancel, or you'll get 3AB equal to AC. So one relationship you got. But we have one more relationship, AC equal to AB plus BC. What is AC? AC equal to AB plus BC. Am I right? So use that here. So what is AC? AC is 3AB. Put that here and bring forward AB. and put the BC as it is. So from this what you get, AB when you take it to the other side, you get 2AB equal to BC, or AB by BC equal to half. Okay, or AB equal to, actually this step is not required. So AB is equal to half of BC. So maybe we don't need to do this. This cancel off. So AB is equal to half of BC. Am I right? So AB is equal to half of BC. We know the time taken to travel BC from C to B or BC is 6 minutes, and AB is half of it. So which means the same van traveling at uniform speed will take half of the time taken for BC. That is, it will take half of 6 minutes, 3 minutes to travel BA, which is nothing but reaching the bottom of the tower. Okay, I hope you have understood it now. Please go through one more time, then it will become clear. Let me recap. So first thing, we are trying to find AD in terms of AB, okay, from this triangle. And next we are trying to develop another relationship between AD and AC using this triangle, the bigger triangle. Equate the AD which you got from this triangle and as well as from the bigger triangle. You get this kind of a relationship. Okay, then cancel everything, get a relationship between AB and AC. Then you also have one more relationship or equation which says AB plus BC equal to AC, and substitute all these things and you get a relationship between AB and BC. Write AB in terms of BC. We finally find AB is half of BC. Okay, this is good enough. We know the time taken to travel BC is 6 minutes. So which means the time taken to travel AB will be half of it, and half of 6 minutes is 3 minutes is the time taken to travel to the foot of the tower. Okay, so this is how this problem needs to be worked out. Please go through this one more time, it will become clear. Thanks for watching this video.